as I share the same circle, our unit circle, with what I'll refer to, not mathematically known, but if you think of a compass, this is our north, our south, our east, and our west points. Now, how do I achieve these coordinates? I'm moving one to the right and then not going up or down, not going left or right, moving up one, and so on for the left and the lower point. So remember, CBS, cosine always comes before sine. So I'm going to circle this time the first value in the ordered pair. Now, when we did sine, we thought of it as a hill and then a valley for our 4 steps. We started here, we went 1, 2, 3, 4, if you watched the previous video. Cosine works a little bit differently. So the number in front of the cosine is a hidden 1. And so I'm starting with, at this point, I'm starting here with an output of 1. 1 times the hidden 1 is still 1. 0 times 1 is 0. Negative 1 times the hidden 1 is negative 1. And 0 times 1 is 0. And my 4th step, 1 times 1 is 1. So when we do this, would be 1 cycle. Now if I continue this, it's going to go back, down, and then back up. So the verbiage I use, which is not mathematical verbiage, but just helps you think of it in terms of land formations, is you start at the top of the hill, you go to the valley, and then you end at the very top of the hill again. 1 cycle is hill, valley, hill. Now let's talk about the length of the period. I'm going to take 2 pi and divide it by the number in front of the x, which is a 1. 2 pi divided by 1 is 2 pi. The x scale, or the length on the horizontal axes for each of the steps, so step 1, 2, 3, and 4, is you're going to take this value and divide it by 4. When I divide it by 4, it reduces to 1 pi over 2. So this would be 2 cycles. Each cycle is a length of 2 pi. So 2 pi and 2 pi is 4 pi, and then 2 pi to the left. Since we're moving to the left, it is a negative 2 pi. Let's look at number 11. All right, so for number 11, we've changed up instead of having a 1, it's a negative sign. And just like sine, remember sine goes hill and then valley, but when there's a negative, it reverses it. The same thing's going to happen. We are going to reverse it, and we'll see how this works. So this is my starting position. 1 times negative 2 is negative 2. 0 times negative 2 is 0. Negative 1 times negative 2 is 2 for step 2. Step 3, 0 times negative 2 is 0. And step 4, entering the first cycle, 1 times negative 2 is negative 2. So a normal cosine curve goes hill, valley, hill. But when there's a negative out front, we've stretched this function because now going from the midline up to the highest point or lowest point is a distance of 2. The negative sign reverses it. So instead of going hill, valley, hill, it just simply reverses it. This is 1 cycle, and then I'm going to continue. All right, now what is the length of a period? I'm going to take 2 pi. I'm going to divide it by the number in front of the x, which is a 1. 2 pi divided by 1 is still 2 pi. Dividing this by 4, so 2 pi divided by 4 reduces to 1 pi over 2. So this is still just the length on this particular function of 1 pi over 2, or also known as just pi over 2. We have 2 cycles. Each cycle is 2 pi. So this is 2 pi, and 2 pi is a distance of 4 pi. And reversing it, we have negative 2 pi to the left. Let's number 12. So the number up front is positive. So I'm going to anticipate hill, valley, hill. And this value, because it's greater than 1, will stretch it. So the distance from the midline to the highest or lowest point will be greater than the original parent function. The parent function we can see up above. The parent function has an amplitude of 1. Why? Because the distance from the midline to the highest or lowest point is a distance of 1. Okay, let's look now at number 12. So number 12, I'm going to take 3, the value out front, and I'm going to multiply it here by the starting output cosine value of 1. 3 times 1 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. 0 times 3 is 0. And 1 times 3 is 3. This is 1 cycle. Now we're going to continue. So I'm going to go down, down, back, and up. Hill, valley, hill. It's important to make these dots to try to sketch an accurate function. Now let's figure out what the length of the period is. The number in front of the x is a 1, so when I take 2 pi and divide it by 1, it's just 2 pi. When I take 2 pi and I divide it by 4, it again reduces to pi over 2, or 1 pi over 2. So each step here on the horizontal axis is a distance of 1 pi over 2. I have 2 cycles as I move to the right, so 2 pi plus 2 pi is 4 pi. And now let's take a look at number 13. 13 changes it up. 1, 2, and 3 had a number in front of the cosine function that stretched it, and in some cases it even reflected it across the x-axis. Now I have, if I rewrite this, I have y equals 1 cosine of 1/2 x. Well, let's see what this looks like. So 1 times 1 is 1, 1 times 0 is 0, 1 times -1, 1 times 0 for step 3, and to finish out step 4, 1 times 1 is 1. So this is one cycle, and I'm going to continue that pattern of that wave curve, down and then up. Make sure you're making your dots to make an accurate sketch. So let's figure out the length of the period. I'm going to take 2 pi, and I'm going to divide it by 1/2, the value in front of the x. When we divide fractions, we multiply by the reciprocal of the second fraction, in this case to end up with 4 pi. Now to figure out the x-scale, or the distance on the x-axis here for each step, I'm going to take this value and divide by 4. 4 pi divided by 4 is simply 1 pi. Okay, each cycle is 4 pi, so this is 4 pi and 4 pi, equaling 8 pi to the right and 1 cycle to the left. Let's take a look at I'm going to start by rewriting number 14. So for problem number 14, I'm going to rewrite this as y equals -1/2. Oh, I don't have to. I quickly picture this as x over 3. Okay, I don't have to do that. All right, so I'm going to refer to this as I go through it. And remember, I normally am hill, valley, hill, but because it's a negative, we're going to reverse it. So it's going to be valley, hill, valley as I make a prediction. Also notice that this time the number in front of the function is between 0 and 1. When this value is between 0 and 1, don't worry about it being negative. That just says we reverse it. So instead of going hill, valley, hill, we reverse the direction. When this value of 1/2, in this case, is between 0 and 1, as we make the shape, it's going to be compressed or pushed down, and we'll see that in this function. So I'm starting at 1. 1 times a -1/2 is a -1/2. 0 times a -1/2 is 0. -1 times a -1/2 is a +1/2. In step 3, 0 times -1/2, and step 4, 1 times -1/2. So we can see that the distance from the midline till we go to the highest or the lowest point is much less. It's compressed down or flattened. This is one cycle. I'm going to continue here. So here's 2 full cycles. And now backwards. All right. So now let's come up here and let's figure out what is the length of this period. I'm going to take 2 pi, I'm going to divide it by the value in front of x, which is 3, so I have 2 pi over 3, and then I'm going to take that, and remember there's always 4 steps for every sine and cosine function, so divided by 4 will tell me if this is the entire length of one cycle, divided by 4 will give me the x-scale, or the distance from one step to the next. So I'm going to divide this by 4. When I divide, really I turn division into multiplication. I take the second fraction and I flip it. So I get 2 pi over 12, which reduces to pi over 6. All right, so I have 2 cycles here. If each cycle is 2 pi over 3, I can take 2 pi over 3 and take it times 2. So if I take this times 2, from this point all the way out is a distance of 4 pi over 3. I took this times 2, which is the same as taking 2 pi over 3 plus 2 pi over 3. And then I'm going to take one cycle to the left, represented with the negative sign. Let's look at number 15. Number 15 has a -1 hidden in front, And so I'm going to rewrite this here as y equals -1 cosine of pi over 2 times x. All right, so here we go with the outputs. I'm starting here, 1 times -1, 0 times -1, -1 times -1, 0 times -1, and step 4, 1 times -1. So here's one cycle, and I'll continue it to illustrate a second cycle, and then reverse it as I go backwards one cycle. Now let's figure out what is the length of the period. So I'm going to take 2 pi, and I'm going to divide it by pi over 2. When we divide fractions, we keep the first fraction, turn division into multiplying, and flip the second fraction. The pi's are going to reduce to 1. We have 2 times 2 is 4 over 1, which is 4. Now the x scale, so this is 4, and 4 is 8, by the way, and backwards is -4. Now the x scale, the length on the horizontal axis for each step, I'm going to take this and divide it by 4. 4 divided by 4 is 1. Number 16. Now number 16 has a vertical shift, and that's what I'm always going to start with if it exists. So I'm going to go up 2. I've shifted this function up, and now I'm going to cross that out. And I'm working with cosine, which is the first one, CBS, cosine before sine. -2 times 1 is -2. So think of this as our origin. I'm going to go down 2. -2 times 0. -2 times -2 is a +2. -2 times 0. And -2 times 1. There's one cycle. Let's continue it. And now back again. All right, so now let's talk about the length of the period. I'm going to take 2 pi and I'm going to divide it by whatever value is in front of the x, which is a 3/2. When we divide fractions, we're going to keep the first fraction and we're going to turn division into multiplying and take the reciprocal of the second fraction. So I have 4 pi over 3. 4 pi over 3. So that's one length of a cycle. So 4 pi over 3 plus 4 pi over 3. So 4 pi over 3, I have 2 cycles to the right, 1 cycle and 2 cycles. So that would be a length of 8 pi over 3. 8 pi over 3 to the right, and a -4 pi over 3 to the left. Now, what is the scale factor or the length along this horizontal axis? I'm going to take this value, I'm going to divide it by 4. So 4 pi over 3 divided by 4. And like I showed down here, when we divide fractions, I can move this down. 4 pi over 3, turn division into multiplying, and take the reciprocal of 4, which is 1/4. So I have 4 pi over 12. 4 pi over 12 reduces to 1 pi over 3. 1 pi over 3, 1 pi over 3, each one of these lengths of a step here, because it's step 1, 2, 3, 4. Each step on the horizontal axis is a length of 1 pi over 3. For problem 17, again, I'm going to start by recognizing I have a vertical shift of down 1. I'm going to come back up here and cross it out. Okay, so the number in front of the function 2 tells me that this function is going to be stretched by a vertical factor of 2. So 1 times 2 is 2. From here, I go up 2. 0 times 2 is 0. Step 2, -1 times 2, down 2. And 2 times 0 is 0. And 2 times 1 is 2. This is one cycle, and now I'll continue that cycle. So I have 2 cycles to the right and 1 cycle to the left. Okay, now the length of the period, I'm going to take 2 pi and divide by the value in front of the x, which is 3 pi. The 2 pi's are going to be simplified into 1, and I'm left with 2/3. So one cycle is 2/3, and now I have 2 circles to the right. So 2 groups of 2/3 would be 4/3. So the maximum on this graph that I can see is 4 pi over 3. As I move to the left, it would be negative 2/3. The scale factor, what is the length on this horizontal axis for each step? I'm going to take this value of 2/3 and I'm going to divide it by 4, which means I turn division into multiplying, and I take the reciprocal of 4, which is 1/4. I get 2 over 12, which reduces to 1/6. Each one of these steps on the horizontal axis is a length of 1/6.